Welcome. In this session, we will see how we can find absolute extrema over closed intervals. We will look only at functions which are continuous in the interval and have only a finite number of critical values in that interval. If the function is continuous in a closed interval, we know there is a maximum and a minimum. And we also know that absolute maximum or minimum is not at one of the endpoints. It is also a relative extremum, so it's a critical value. So we find all the critical values of the function in that interval. Then we evaluate the function at the endpoints, which can be absolute extrema without being critical values, as well as the critical values we found. And now we take the largest and smallest in this list, and that must necessarily be the absolute maximum and absolute minimum. Let's look at some simple examples of this process. We will find the absolute extrema of x cubed minus 3x squared minus 9x plus 11 over the interval from 0 to 4. We found the critical values earlier. Find the derivatives at it equal to 0 and solve, and that gave us negative 1 and 3. But our interval of interest is 0 to 4. Negative 1 is not in that interval. Only 3 is. So we evaluate the given function at the endpoints 0, where function is 11. 4, f of 4 is negative 9, and the critical value in that interval, f of 3 is negative 16. Of the three values, 11, negative 9, and negative 16, the smallest is negative 16, so that's the minimum. 11 is the largest, so that's the maximum. It works the same way no matter how many critical values you have, as long as it's a finite list, which will be the case for all elementary functions. Next, let's find the absolute extrema of x minus 2 power 4 times x minus 4 squared over the interval from 3 to 5. Again, we have done the hardest part, which is finding the critical values. They are 2, 4, and 10/3. Our interval is 3 to 5. 2 is too small. It's not between 3 and 5. But 4 and 10/3 are. So evaluate the given function, the two endpoints. 3, where f of 3 is 1, 5, f of 5 is 81. The two critical values inside that interval, f of 4 is 0, and f of 10/3 comes out to be 1024 over 729. The smallest value among these four, 1, 81, 0, and this fraction, which is 1 point something, smallest is 0, so that's the minimum. The largest is 81, so that's the maximum. Finally, let's do an example where we have to start from scratch. We're finding the extrema of x power 5 minus 15x cubed over the interval negative 4 to 2. First, we find the derivative. This is a power rule. Derivative of x power 5 is 5x power 4. Derivative of 15x cubed is 15 times 3x squared, or 45x squared. To find its zeros, I'm going to factor. Can factor out 5x squared. Other factor will be x squared minus 9, and x squared minus 9 factors as x minus 3 times x plus 3. So f prime is 0 at 0, 3, and negative 3. Since f is a polynomial, it's always differentiable. So the only critical values are 0, 3, and negative 3. 0 is between negative 4 and 2, so is negative 3. But 3 is not between negative 4 and 2. So we have two critical values in that interval, namely 0 and negative 3. And we also have the two endpoints, negative 4 and 2. We evaluate the function at these four numbers. F of 0 is 0. F of negative 3 is 162. F of negative 4 is negative 64. And f of 2 is negative 88. Of these four values, 0, 162, negative 64, and negative 88, is the smallest is negative 88, so that's the minimum. Largest is 162, that's the maximum. This concludes our look at the process of finding absolute extrema.